So the y-intercept. The y-intercept is easy when your parabola is in standard form. Usually what you'll do is you'll sub in 0 for x, because the y-intercept is the place on the parabola that crosses the y-axis. So the ordered pair will always be 0, comma, some number. When we sub in 0 for x in standard form, you can see that we would get y equals, this term will be 0, this term will be 0, and we'll be left with c. So in standard form, the y-intercept is at 0, comma, c, whatever the constant term is. There will only ever be one y-intercept for any function. Now x-intercepts, on the other hand, those are a different story. The x-intercept is where the parabola crosses the x-axis. So basically what we're going to do is first we will set the parabola equal to 0. So we're going to sub in 0 for y, which means we're setting the parabola, the rest of it, equal to 0. And then we're going to solve. Now when we solve that, it's going to be a quadratic equation. So it will be in this form, ax squared plus bx plus c equals 0. And we can solve that by factoring. We could solve it by completing the square. Or we could solve it by the quadratic formula. You're always going to give your answer in terms of a number, comma, 0. And there might be one x-intercept. So we could have a parabola that has one x-intercept. We could have a parabola that has two x-intercepts. Or we could have a parabola that has no x-intercepts. So there might be 1, 2, or 0 x-intercepts. The next thing we're going to look at is where is the parabola positive and negative. And that actually has to do with the x-intercepts. Well, I guess I'll make positive and negative. That is an and sign. Positive and negative. Okay. Positive means above the x-axis. Negative means below the x-axis. So you're going to have to know what your parabola looks like in order to answer those questions. We'll just start with a rough sketch here, just of any old parabola. This one happens to open down. And remember that we're giving these answers in terms of the x values as we move left to right from negative infinity to infinity. Now positive means the graph is above the x-axis. So that would be, basically if you cover up your x-axis and just look above it, if you cover up like that, that is where our graph is positive. So it's positive between this point right here, positive, 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 all the way over to this point. Now the graph is negative below the x-axis, so if I cover up above the x-axis, this is where my graph is negative. So it's negative, 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 and then again over here, negative, negative, negative. So if we look at the x-axis, you can see that it's negative in this zone and in this zone, but then it's positive in this zone. Now those have to do, those values where it crosses over happen to be the x-intercepts. So here is x-intercept number 1, here is x-intercept number 2. So you're going to want to give your answers for positive and negative using x values. So we will use x values. They happen to be the x-intercepts to list the intervals. And we always want to go starting at negative infinity and ending all the way over at positive infinity. So in this particular problem, it would be negative, in my example, it's negative from negative infinity to x-intercept number 1, and then it's positive between x-intercept number 1 to x-intercept number 2, and then it's negative again, so I'll use this U symbol. It's negative again from x-intercept number 2 to infinity. Now you're really going to have to pay attention to your picture in order to be able to list where the parabola is positive and negative. The last two things that we want to talk about are domain and range. Now the domain for all parabolas, domain is the x values that are defined for the function, and all parabolas have a domain of negative infinity to infinity. The range will be different depending on if your parabola opens up or down. So if the parabola opens up, then your y values start from the y value of the vertex and go up to infinity. So the range would be the y value of the vertex to infinity. If your parabola opens down, the range would go from negative infinity up to the y value of the vertex and have a closed bracket.